First, welcome to join Radio Technology Training, and I'm very happy to have discussed with you together. And this training will have long time, nearly 8 working days, and every day we have 3 hours to talk about the technology. Okay, because now I am in my room, and my room is a little big, so maybe the voice is not very clear, but I'm trying my best. Okay. So before we talk about the detail, let's have a brief introduction about myself and also introduction about this course because we have long training, not only for 3 hours. So about myself, my name is Emily, and this is my email, and I am the trainer of Radio Global Training Center, and I do the training over 6 years, focus on the technology like router, like switch, like wireless, security, something like this. This is me, and also I hope if in the future maybe you have seen some video on the other places like the YouTube, you also can see this is me, Emily. And about this course, our course we have nearly 8 working days in online course. So if you focus online on your computer, it's a little tired and maybe a little boring. But I will try my best to make the training more interesting. And our course will begin from August today to the next September 8th. September should be 7. Sorry, should be 7. And the GTM is past 8 and nearly 8 working days. And I think everyone already received the email, right? From the Radio International, sent to the detail of the training scale. And every day the time is from 2 o'clock p.m. to 5 o'clock p.m. And we will discuss 2 parts. One is wireless technology and another one is wireless technology, second parts. And the first week, from Wednesday to Friday, we will talk about the wireless technology. And the next week, we will talk about the wireless part. So this is the whole arrangement of the training. And before I talk about the detail, I have some questions for you. Maybe in the training, I will have so many questions I want to discuss with you, but we have lots of people. So if you have the answer, please write down of the training, of the WeChat, of this laptop, of this platform. And the first question is, what are the common types of network devices in communication networks? Do you know? Maybe you are a very professional engineer. Maybe your first time to learn the technology of communicate network. So what the types of network devices do you know? Please write down the answer on the chat, and later I will discuss with you something like this. What type of network devices do you know? Everything you know. Maybe you can write down. AP, yeah. This is the first answer. Router, gateway, PLE, and other. Okay, please wait a moment. I have to do the translation. Okay, I see so many key points. Hub, right? Wait a moment. I have to translate this one. Okay. So I have seen so many answers. Someone say router, someone say hub, someone say switch, also someone say AP. These are network devices. Yes. Okay, and the next one answer. If we already know some devices on our network and we maybe connect to all the devices together, and make a topology, and then we will use so many technologies on these devices. So the second question is, what technologies are commonly used in communication networks? You know, can you share me some answer? Can you share with me what technologies are commonly used in the network? Any technology you use? Maybe you already use. Maybe you see some configuration on the other one, the network. You also can write down for me what technologies are commonly used in your network. No answer? DHCP, yes. Yes. Any other? Else except the DHCP?
VLAN.
VRRP. Yeah, someone said VLAN. And anything else? No more? Yes, VLAN. L3 roaming. Yes. Okay, so maybe someone already tell me some key points of the technology. Yes, the TCP/IP. This is a very big protocol family of the TCP/IP. We have lots of technologies on the TCP/IP. Okay, and why we have these two questions? Because maybe in our network, the key point of the topology, the devices we use, maybe we can divide into router, distribute switch, access switch, maybe also can provide some function of the PoE. And also we have some terminal, right? Maybe a lot of people focus on the network devices of the router of the device, something of the switch, something like this. But the most devices we use, maybe it's your phone, maybe it's your laptop, maybe it's your personal computer. All of this we or is terminal. And if we buy so many devices on our network, and we have to use a cable to connect with each other, right? And maybe we use the network cable, maybe we use a fiber, and maybe we will use the wireless part like the Wi-Fi to connect with each other. So then let's say if we want to communicate with each other, for example, now I'm online training, and why you can listen my voice, why you can see my presentation, because we already distribute our network on the internet, and then we can transfer the message on the line. And the first, for example, the simplest network we will use maybe is we have two laptops or maybe two computers, and we want to communicate with each other. For example, I want to send a presentation for you. Maybe we can, if we have short distance, we can directly to use the cable to connect with each other, right? And the basic we have to use is IP address, right? We have to give the right IP address. Then we can maybe open the application and then send the message. So this is the basic one. Someone maybe say IPsec is too easy for me. Why we have to talk about the IPsec? Because you maybe in the future you have to do the planning, how to plan the IP address in your network to let every devices like the router, like the switch, like the terminal, why they have to use this IP address, not the other one. So this is the first one about the IP address. And the second one, maybe your network will become bigger. That means my computer maybe on the first floor, but the other computer on the second floor. So if they want to communicate it with each other, if you use the cable directly to connect with them, maybe the distance is too long for the terminals. So in this time, we have to use another devices we call it switch. And we will use a cable to connect with the switch. And about the switch, we will talk about the principle of layer 2 switch. If the switch receives a message, how to forward it, and how to forward to the destination, or maybe sometime we will discuss the packet. So this is the second one. And then maybe our network will become more complex. For example, we have lots of terminals, and they may be located in different buildings, and they want to communicate with each other, and we will connect more devices. And about the principle of the switch, later we will talk about the detail. Switch will broadcast the packets. So if this flood the rent is too big, maybe there's some bandwidth wasted. So how to solve this problem? We will have a new technology. This technology we call it VLAN, to divide different terminal into different VLAN. And the next one, on this topology, if one switch or maybe one link is broken, the communication cannot work. So how to make the network more complex, more availability to provide the higher availability. We also have so many technologies. The basic one, we have to connect with multiple devices, and one is the main device, and another one is for backup. In this time, if one link is broken, maybe we also have the second path. And on the distributed switch, we also can have a link with each other. And in this time, if this link is broken, and the information still can be forwarded through this path. So this is a backup. But in this topology, there is a loop, right? Maybe there is a loop. And if the loop happens, the network will be broken. So how to solve the problem? I want the redundant path, but also I want to avoid the loop. And we also have the technology like STP. And about the STP, we can meet the requirements. And another one, between the distributed switch, maybe we have the high bandwidth interface. We hope all the interface can work normally, and we will provide multiple links to connect with each other, and we hope all the cable can be forward the traffic. Because if we use the STP, one interface will be broken. So how to use everything? We have to use technology like link aggregation. Yes. About another one, if we want to combine all the devices together to become a logical device, this technology we call is VSU. And another technology is DHCP. I already see someone write down the correct answer, because in your network, if you have lots of terminal, and they also want to get the IP address then to get the internet, the best solution is we have to deploy the DHCP, because the static IP address way is too complex and too overworked for the engineer. So this also is a key point we will discuss about the DHCP. And the second one is the VRRP. And the DHCP and VRRP usually is used for the terminal to provide the high ability to reach the internet. One scenario of the VRRP is, for example, if the gateway is broken, the terminal cannot reach the internet. So we can provide the virtual gateway for the terminals, and this technology we call is VRRP. And the next one, for upper, if we connect with the router, maybe it's your EG, maybe the other devices, connect with them together. They will forward the traffic based on layer 3 information. So we have to first keep the correct path to forward the traffic. And how to configure the correct path. About this part, we will talk something of the layer 3 routing information. The first one is direct route and static route. And another one, if your network is very big, maybe we will use the dynamic route protocol like OSPF. And if you deploy everything, this protocol on your network, you can meet the requirement. The terminal within the same segment, or maybe between different segments, they can communicate with each other, right? If you know everything about this technology. But another new requirement is I want to keep the network more security. For example, if your leader wants to wait some resources, it is allowed. But about the other guys, they only can wait some destination maybe within a certain time. So how to control the traffic? We can use the technology of ACL, Access Controller List. So how to make the rule and how to define the devices. While I receive this message, I can forward, but the other one I have to discard. Just because we do the ACL to do the control. This is the ACL. Of course, if you don't deploy the ACL on your network, everything can wait with each other if you already know every technology on the upper protocols. And the next part, maybe now we want to wait the internet. And someone say, I can directly wait the internet, but in effect, our IP address is divided into private IP address and public IP address. That's because IPv4 address is not enough. So in your LAN, your local area network, you want to visit the internet. Another new technology you have to use is NAT. Okay, is NAT. So this is the next technology we will discuss. This is a network address translation. So every part of this technology we will discuss on this week. Lots of practice and lots of technologies. And each part, when we talk about, I will give you some example. I will explain what's the principle, and also we will discuss some with some questions, and then we can do better. So this is about the where the part. And later, maybe your network will be more different. Not only about the where the network. Some users, some guests to visit the company, you also have to deploy the wireless technology, right? So maybe you will add a new devices, someone say is AP, and also maybe you will say a new device is like AC. So the second week, we will discuss of the technology. The first one is WLAN basic. Maybe someone already know some words of the wireless like SSID, like station, like AP, like AC. So what's the difference? What's the definition and how to work? So this is the first basic we have to discuss. And everything in the network, how to follow the traffic, we have lots of protocols. And about the wireless part, the main protocol is IEEE L2.11. So what's the difference of the L2.11? Someone will say Wi-Fi 6, Wi-Fi 5, Wi-Fi 4, and maybe IEEE, ABG, and what's the difference? Everything we will talk about is on the second part. Then the next one is a key point, because you maybe already do the configuration on these devices. One we call it FAT AP, and another one we call it FIT AP. So what's the difference? Well, which scenario we will choose FAT AP, which scenario we will choose FIT AP. So this is the first three parts. And later, if you deploy the wireless network successfully, we want to provide the network better to improve the experience for the customer. So the other technology we will talk like WLAN roaming, WLAN optimization, redundancy, and site survival. So these are the topics we will talk on the second week. This is for the wireless part. So after this training, I hope, because about this part, we only talk about the technical principle and the key command we will use in our network. I don't provide the lab, so maybe in the future, if we have the chance, I also will provide the lab for you. Everything we finish, I hope you can deploy a topology or maybe a network like this topology in your network. You can know everything. Why the customer can visit the internet, what's the principle, something like this. So the training schedule, I think everyone already received the email, right? We divided into two parts, the public basic for the web technology and the second one for the wireless. And every day we will have 3 hours from the 2 o'clock p.m. to 5 o'clock p.m. for the Chinese time. and the time from August 29 to the last September 7. So this is a training schedule. So about this part, everyone is clear why we choose this technology of the training. That's because I hope when you deploy the network, when you do the project, you can know everything. This is a basic technology. So about the schedule is okay for you, right? And if this part is okay for you, maybe the next one, I have a brief introduction about the platform. Maybe someone's the first time to use the lab. And this tool is very similar like the Zoom. And the first one, the left part is the ID. Please remember the ID because the next every day we will use the same ID to have the training. The second one, this is the member. Everyone joins the training, you can see. And the next part is the presentation page. Maybe you can directly say now. And the next part is the microphone and the camera. Because we have lots of people, maybe it's not so many chance to open the Microsoft, but you can write down everything on the chat window if you have any problem. And the next part is how many participants and everything you can write on the chat window. And now I'm share the screen and I also record the video and later I will share you the video. And you also can give some reactions and some more points. And after this training, you can leave. So this is a platform. I hope you can use conveniently after this training. And also we have the group of the lab group. And in the group, maybe I will send some reminder message. For example, 5 minutes later, we will begin the training. So if you download the app, maybe you can scan it and join. Or maybe later, you remember the time, you also can direct join. It's okay for you. So this is the information of the platform. And the next part, let's have some conversions. The first one, please try to mute your phone and devote yourself in the training because we have the long discussion. So maybe a little boring. The second one, if you have any questions during the training, please leave a message in the chat box in time. Okay. Also, maybe you in the later group, you also can write down some information. After the training, I will check the message. And the third one, after this training, the training record will be sent to uniformly. So if you already registered the format in the email, see the Google Drive, the format, and if we got the email address from you, we will send you the training record after finish this training. So this all part about the training information. Let's have a brief introduction for you. It's clear for you about this part? Let me see. Maybe someone, it's okay to unmute your voice. Okay. Jenny, I will mute your voice at the beginning. Okay, now maybe let's begin our training topic, right? I think this is the first part you want to know. Let's see. The first topic we will see is IP address. In this training, if you have any problem, you can write down on your chat window and we can discuss later. Okay. I want to. So now let's begin our first part for the IPv4 addressing and the subnetting. This is the basic one because when you deploy the technology on your network, I think everyone and every device is the first step, except use the cable to connect with each other. The first step is give the right IP address, right? So besides the IP address, the other protocol we have to know is IP. IP is the Internet Protocol. This belongs to the network layer protocol because I think everyone knows the reference model of the TCP/IP, right? The main point of the network layer and the main protocols we use is IP. And about this chapter, we have to introduction the basic of the IP protocols. What's the common protocols we use? And if we have the IP address, how to do the subnetting and how to configure the IP address, something like this. The first, after taking this course, I hope you can master the classification of IP address. So someone may be a little confused. What means classification? Because before we deploy the IP address, for example, how to give the IP address like 192.168.1.1, at the beginning, some organization divides the IP address to become classification. So someone maybe know like classification A, B, and C, something like this. So what's the range and what's the key point we have to know about this one? The second one, we have to master the rule of the subnet mask. Now in our network, lots of people will use the subnet mask. So the first we have to see what's the overview and the classification of IPv4 address. First, about the network layer protocol, we have lots of layers, like the network access layer, like the network layer, and the transport layer. These are main protocols we use in different layers. If you are interested in different protocols, maybe you can see the YouTube on the region. I already had some video and explain the detail of each layer. And about the network layer, the main protocol we use is IP, Internet Protocol. And we will use the protocol number to indicate different app layer. For example, the protocol 6 means TCP. The protocol 17 means the UDP. Because we have to provide the service for applet layer. That means we have to let the transport layer know if you delete the IP header, what's the information of the TCP or maybe is the UDP. Because different protocol we will use different mechanism. So how to let the app layer know the detailed information of the TCP or UDP? We will use different protocol number to indicate different protocols. And the other protocol like ICMP, we will use a protocol 1. IGMP, we will use a protocol number 2. Someone may be confused what means ICMP. I think you already use this protocol because in your network, after you do the configuration, the first step, maybe you will use a command or maybe the GUI page to test the connection, right? How to test the connection? The devices will send out the ICMP packets. And then if I send the equal and within the time you can give me a reply, this means the network connection is ready. And this protocol we call is ICMP. And IGMP, maybe we will use in your multicast network. Maybe you have some video meeting, something like this. We will use a multicast message to send the information, but not about the unicast because this information will take a lot of bandwidth. And the next one also is very important for the ARP, Address Retranslation Protocol. This one is very important. And why the ARP is located in these places? Because the ARP will be used for IP address and MAC address together. So if you want to encapsulate the packets successfully, we have to add the IP address and MAC address information. And how to get the MAC address information, we will use the ARP to ask, hello, what's your MAC address? And then I will give the reply. So this is the ARP. And the RARP means, I already know the MAC address. I want to have an IP address. So this is a basic function. And about this part, you only know some basic is enough. You don't need to remember what's the protocol number. It doesn't matter. And the next part is about the IP function. And about the IP function, we have the command for identify the nodes and the link. What means the nodes? IP nodes like the terminal. Of course, about your network devices like the router. And every router, the interface will also have to give the IP address. So the first function, we will use the IP address to indicate the node. And the second function, we will use the IP network address to indicate the link. For example, in this topology, this is a network address to indicate the segment for link 1, link 2, and link 3, something like this. So this is a basic function. That's why later we will take a long time to explain what's the key point of IP network address, right? And what's the broadcast address. This is very important not only for the devices to give IP address, but also for the network devices, how to build the route. So this is a function. And about the IP address, we will have two parts. One is network ID, one is the host ID. This one is very similar like your phone in different country. For example, in China, the first part of the phone is +86. Then everyone will have the unique number. So this is similar function of the IP address in the network. The first network part indicates you belong to the LAN 1, LAN 2, or the other segment. Then in the same network, different terminal or different devices, we will use the unique host IP address to indicate the devices. So this IP address is divided into two parts. And the length is fixed, 32 bits long. Okay, 32 bits long. 32 bits long means we will use the binary 1010 to indicate the information. So the distance long is 32 bits. Something like this. So this is the basic of IP address. And usually we will use dotted decimal to indicate an IP address. For example, here, we will divide the 32 bits to become 4 parts. So each part we have 8 bits long, right? Every part is 8 bits long. And the maximal binary, pay attention, when we do the IP address calculation, we have two formats. One is decimal and another one is binary. So about this part is a little complex maybe for someone because they want to do the calculation before. Okay. The maximal binary means 32 bits long. Every bit is 1 because we only have 2 maps, right? One is 0 and another 1. The maximal one means 32 bits long. Every one is 1. Every bit is 1. So if we want to get the result of the decimal, what's the result? Someone can show me the answer. If we use the maximal binary, what's the result of the decimal? If 32 bits are 1, what's the result of the decimal? Who can tell me the answer? What's the result of the maximal binary? 001. Only 001. No one answer? $255, 6, 6. Any answer? Okay. I think someone gives result, right? 255. So let's see the process. If we have 8 bits of 11111, how to get the result of the decimal? Because we have 8 bits in network, a lot of places we will use the sequence number from 0 to 7. So the function is n and multiply 2 to the power of n. And the n is the value from 0 to 7. And let's see the result. N means the bit of 1 or 0. And from the right to the left, the n will become to 0 to 7. So the result will become 1 multiply 2 to the power of 7. The result is 128. And the second one is 64. And the third one is 32. And the last one is 1. And finally, we have to plus them together. So the result is 255. That's why if the maximal binary is 11111, the result will become 255, 255, 255. This is a maximal decimal. So this is the calculation between the decimal and the binary. And later I will show you the example. For example, now your address is 1100.1010 and something like this. So what's the result of the decimal? From left to right is 0 to 7. And finally, because 0 multiply, everything will become 0. So we can directly skip it. The result is 192.168.5.123, sorry. So usually we will see the IP address like the last one, 192.168.5.123. But pay attention about your network devices, the router, the switch, or maybe your terminal. We only know the information of the binary, okay, of the binary. But when we do the configuration, we only do the IP address like the last one is enough. Okay. And if we give the IP address, we say one IP address, we can divide it into two parts. One is the network address, and another one is the host address. This one also is very important. While the network part identifies the different IP networks. For example, in this topology, we use one router to connect with the terminals, and the left one and the right one. About the left one and the right one, all the terminals or the interface of the router, the network part will be same. Okay, but the host part will be different to indicate different IP node in the network. So if you deploy a router or maybe a layer 3 switch in your network, when you track the routing table, you can see lots of routing information, right? In each routing information, we will use the network address to indicate one segment. Yeah, so this is a routing table. Routing table is very important because if the router or layer switch, we want to follow the traffic between different segments, we will check the routing table and according to this information, then follow the traffic. So this is the routing part. And about the IP address, someone say, now we know if you use the IP address, we will use like 192.168, this format to indicate the IP address of the devices. And how to get the network part, how to get the host part. Why we say the first 3 bits is belong to the network part, or maybe the first 24 bits belong to the network part. Because all the devices to follow the traffic, the first step, you have to do the judgment. You belong to the same segment or not. So we have to give this information to let the devices know the destination is same with the source or different. So how to give this clarification? At the beginning, the organization is divided the IP addresses to become several classifications. Become class A, B, D, and E. So what's the range? Let's see this process. Each classification will also have the same length, 32 bits long, and the sequence number from 0 to 31. Okay. And about the classification A, pay attention. The first 8 bits, the first part is the network part. The last 24 parts belong to the host part. And the first bit is fixed. It must to become 0. And all the other network parts will become freedom. You can use everything. So what's the range of the classification A? If you want to get the range, you only to calculate the smallest one and the biggest one is enough, right? So what's the smallest one? The range means smallest one, except the fixed bit 0, make the rest of them to become 0. So this is the smallest, will become 0.0.0. But the maximal IP address means except the first bit, the rest of them to become 1. So this will become the biggest range. So the result will become 0.0.0 to 127.255 to 455, 255. So this is the range of classification A. So if you have two IP addresses within the classification A, you only to compare the first 8 bits. If the first 8 bits is same, they will belong to the same segment. It's very easy for you, right? And then is classification B. About the B, the first 16 bits is the network part. The last 6 bits is a host. And the first 2 bits is fixed, 1 and 0. Also, we have to calculate the smallest one. Smallest one means the rest of them to become 0, right? And the biggest one is makes the rest of them to become 1. So the range will become 128.0.0, 191.255, 255. So this is a range of classification B. And the next part is classification C. About the C, 24 bits is the network part. Only last host will become the host part. And the fixed number is 110. So the range also C will become 192.0.0 to 223.255 to 255. In the classification A, B, and C, usually used for the network communication. For example, you allow for the terminal or maybe for devices. So this is A, B, and C. And the next part is classification D. This address usually used for multicast training. Okay, for the multicast information, we have to forward and to give the multicast address. And the range is from 224.0.0 to 139.255. So maybe when you do the configuration on your network, you only give the IP address from A, B, and C, right? You don't give the IP address like 225, right? Because this belongs to the classification for multicast. Only in the special application. For example, maybe you have some video meeting, something like this, you will use this address. Otherwise, you only use the address from A, B, and C. And the last part, this address is reserved. So you only remember this one is enough. So we have to focus on the subnetting later on A, B, and C. And on these devices, some special IP address cannot be used for the devices, also maybe for terminal, also maybe for router. The first one is network address. What means network address? Network address means makes the host part to become 0. And the network part can be any. And this address we call is network address. And about network address will indicate one segment. That's why in your maybe in your router, maybe in your switch, in the EG, when you check the routing table, you will see so many addresses like 192.168.1.0/24. This is the address of the network address. And the second one is a broadcast address to make all host parts to become 1. That means indicate all nodes. Pay attention, these two addresses cannot be used for customer or for the devices. Okay, and another one is the network for 127, and the host can be any. This is a loopback address and used for local. Also, you don't give any configuration on the devices. You can see the address of 127. This one also cannot be used. And another one is 32 bits to become all 0. So the result will become 0.0.0.0. This is a default root, also cannot be used for customer. And all 1, the result is 255, 255, 255, 255. This is a all node broadcast. So this address also cannot be used for customer. So except this special IP address, let's see the back of the IP address classification. The range is different for classification A. The correct range from classification A is 1.0.0 to 126.255.255.255. So this will be the correct classification A IP address. Okay, so this is a classification. And in this process, if we now know what's the range of the classification, and the other one is how to calculate the number of IP address. This also is very important. Maybe your customer say, now I need one IP segment, and in my network, maybe we will have lots of terminal and the IP range should be 200. Please plan an IP address for me. So if this requirement, what IP address you have to plan for customer? Or maybe someone say, in my office, I only have 2 computers. Or maybe in the future, my office number will become 30. Please give me the correct IP segment. So you have to know if you have an IP address and you have the mask, how to calculate the number of IP address. That's why you can direct the next step, you can do the configuration, because the first step is the planning. And who will decide the length, the number of IP address? If we make the network base load to become N, the host path to become N, who will decide the number of IP addresses? The network number M, which will determine the number of different network segments. And the number of IP segments is 2 to the power of N. The host number N, which determines the number of IP address, right? For example, you have 3 departments. One department, we need 200 IP address. And another department, we only need 20 IP address. And the last one, you also have to give an IP address for 2 routers connected with each other. So this is a requirement for you. That means we need 3 segments, and each segment, the IP address is different. And the host part will decide the IP address number, and the number of IP address is 2 to the power of N. And the N will determine the different network segments. Pay attention. When you calculate the IP address, the available IP address is different. 2 to the power of N, and you have to minus 2. Why we have to minus 2? Because one is network address, and another one is a the broadcast address. These 2 addresses cannot be used for the terminal. So at least maybe you can have a review in your network. The longest mask will become 30. You cannot use 31, because if you use 31, you only have 2 addresses, one for the network and another one for the broadcast. So pay attention about this part. And besides this one, when we do the IP address in our network, we also divide several IP address to become the private IP address. Okay, and the private IP address is used to save the IP address. So we divided the address to become public and private. And about the private IP address is classification A, range to become 10.0.0 and 255, 255, 255. And classification B and C, all of them will have the private IP address. And about the private IP address, different company, different department, we can use them at the same time. It doesn't matter. But if you want to visit each other, for example, you want to visit the internet, you have to translate the private IP address to become public. Otherwise, maybe there is an IP address conflict. And this technology we say is the NAT, network address translation. Or maybe your branch wants to visit the headquarters, you have to use the VPN, virtual private network, and add the private message into the public message, and then the devices can follow the traffic according to the public part. So in this solution, we can save the IP address, right? Because different company, we can use the same IP address. So pay attention about this part. About the detail, how to do the translation, maybe last day when we talk about the net, we can talk about detail. This is a private IP address. Okay, this is a technology we call, I already said before, we have to use the network address translation. And the next part is the subnetting. The subnet mask, this one is very useful because we say at the beginning, we will divide the network to become classification A, B, and C, right? A, B, and C. And different classification, we have fixed the network part. Classification A, the first 8 bits is the network part. The last 24 bits is the host part. Now pay attention. If you use the classification A, what's the disadvantage? If you have one segment, in this segment, you have lots of IP address, 2 to the power of 24, maybe -2. Now pay attention. Maybe your company, your own this department, you only need 200 IP address, but the rest of the IP address cannot be used for the other department because they belong to the same segment. So we hope we can have a technology to divide the big IP segment to become several, and we can assign this IP address for different departments. So this one we call a subnet mask. And in the subnetting, we will use the subnet mask to let the devices know which part belong to the network part and which part belong to the host part. And we will use 1 and 0 to do different represent. The 1 represents the network bit, and the 0 represents the host bit. And pay attention, although maybe you directly use the classification address, or maybe you use the subnet mask, the long distance is fixed, is 32 bits long. Pay attention about this one. So, for example, now maybe in your network, if you only see the IP address 192.168.1.2, at the beginning, maybe you will see this is a classification C, and the last 8 bits is a host bit. But now we already directed to give the subnet mask together. For example, like this one, 255, 255, 255, and 0. Because about the second part is a mask. The first 24 bits are 1, right? And the last 4 bits are 0. So the first 24 parts is the network bit, and the last 8 parts is the host bit. And as a result, we usually use this format, 192.168.1.2/24 to indicate an IP address. So this is a subnet mask. And about the classification, there is default mask. And the default mask is a special classification of the subnet mask. For example, about class A is 255.0.0. We usually use /8 to indicate the IP address. And the B is /16. And class C is /24. So this is a default mask for the classification. And the next part is a VLSN, Variable Length Subnetwork Mask. And we can use this technology to divide the network into subnets of different size. What mean different size? For example, now our subnet Our IP segment is 172.16.0.0, and the mask is /60. And we want to use the big segment to divide the different departments. How to divide them? We can use this one first to make the mask from 16 to 24. So we will have the segment of 256. And then maybe one department, we don't need the IP address like 256. This number is too big for me. We can continue to make the mask longer and then to more efficient use of the IP address. For example, now about this segment of 254.0/24, we can continue to use the mask to become 30. And each segment, the IP address is 2. The valued IP address is 2 because one for the broadcast and another one for the network address. And the rest of the last segment, we also can use /32 to indicate one IP address. Of course, pay attention about the last one. We usually use the mask of 32 for the loopback address. Okay, so if you use a mask of 32, every IP address will be different. Pay attention about this part. And the next step is how to use the subnet mask to correctly indicate the IP address. We can change the subnet mask to divide a large network and then to become several smaller networks. But pay attention, the biggest IP address is C. For example, now you divide a classification C. The big IP address is 256. If you use this segment and to do the subnet mask, every segment, you can have several segments, but each segment, the IP address is less than 256. Pay attention about this part. So before we do the subnet mask, we have two level IP address. One is network part and another one is host part. And after we do the subnet mask, we will have 3 level IP address. And we will have a new one for the subnet. Pay attention. Although we have 3 level IP address, the distance, the length is fixed. Network plus subnet and add the host, the distance is fixed and the length is 32. Pay attention about this one. So the number of subnet mask, for example, I have 1 cake. How many small cakes you can use depends on the subnet number. And the format is 2 to the power of x. And the x represents the number of the bits in the subnet mask. But if your subnet bit were bigger, that means your host part will be smaller, and your host part will define your number of IP address. That means how many IP address can be used in your segment. And the format is 2 to the power of n and minus 2. Please remember it. If your x is bigger, your y will become smaller. That means you can divide one segment to become several departments, but each department, the number will be less. So pay attention about this part. For example, we have the classification state. The network segment is 192.168.10.0/24, right? The default mask is 24. And the total IP address is 2 to the power of 8. So the number is 256. And that's because your mask is 24. So your host part will become 32 minus 24 to become 8. And the 8 will decide your total IP address. And the mask, like a knife that cuts the network segment. For example, about the circle, we have 2 to the 256 IP addresses. Then you can direct it to cut half and half. Then the result is you can use the mask of /25. And the segment is 192.168.10.0/25. And usually you can use the IP address from 0 to 128. 28. That means 128 IP address you can use. And another one, if the next department, I don't need so many IP address, maybe half is enough for me, you can continue to cut /26. But the range, pay attention, the first IP address should become 192.168.10.128. You cannot use 192.168.10.0 because this IP address already used by the right one. And about this part, you can use totally 64 IP address. Of course, you have to minus 2 address, right? Each segment, the network and the broadcast IP address cannot be used. And the next part, you can continue to make the range smaller, the mask to become 27. And the next part, you can use 24 to give the next department. So if we use this subnet mask, we can divide one class C segment to become 1, 2, 3, 4, 5. Five segments, right? But each segment, the number will smaller than 256. Pay attention about this one. And another one is different segments. The IP address cannot overlap. Okay, pay attention about this part. If the 192.168.10.1 already used for one segment, and another one should be the new segment. Pay attention about this part. Okay, we will continue. We already see the subnet mask example, right? If we do the classification and use the subnet mask, like a knife to cut a big segment to become several segments. So one bigger IP address we can use for different departments. And here we will have some example. For example, now we have one classification A, the IP address is 10.1.1.2, and now we will use a mask is 30, 255, 255, 255, 252. So here the question is, in the same segment, what's the other IP address? This may be, for example, the scenario like this. The technology department, we have 2 people, and one guys we already use the IP address for 10.1.1.2, 255, 255, 255, and 252. And how the other guys should be use IP address? What the IP address is the other guys have to use. That's why if you already know one IP address and know the mask, you have to know how to get the other one in the same segment, right? This is the purpose for the example. And how to get the other IP address? For example, now we can first to make the IP address and the mask to become the binary, like 001, 001, something like this. And the mask is easy because the 1 is continuous. Maybe in the mask, you will not see the value like 110, 110. No, this only the binary format for the IP address, not for the mask. About the mask must be 11111 and then the 000, something like this. So the binary result is like this one of the IP address and the mask. Then we can divide the left part into the network part. The right part becomes the host part, right? And the other address means we can use the last 2 bits to become any value. But we only have four scenarios, right? Like 00, 10, 11, and 01. 4 scenarios for this segment. So the result is the binary representation of 10.1.1.2 is about the last 2 bits to become 4 scenarios. 00, 01, 10, and 11. So there are 4 combinations of the last 2 bits. Pay attention. There are only 4 IP addresses can be used because we only have 2 bits of the host. And according to the format is 2 to the power of 2. So we only have 4 IP addresses. Pay attention. The actually IP address is only 2 because we have to -1 for broadcast and -1 for the broadcast. So only 10.1.1.1 and 10.1.1.2 can be used. The mask is 30. And the 10.1.1.2 already been used. So the other one only can use 10.1.1.1. Pay attention. If in your company, this department, you use /30, if we still have the other guys, they cannot use the segment IP address because this is a limit of the mask. Maybe you can make the mask shorter and get more available IP address, but you will minus the segment. Okay, so this is an example for the classification A. Of course, if you have the classification B, the same requirement, the calculation is C. Pay attention. And about the classification B, for example, the segment IP address is 172.16.0.0 and the mask is /16. Then the requirement is divide a class B address into multiple class C addresses. Because about the class B, we have lots of IP addresses, right? The number of available IP address before subnetting is the format 2 to the power of 16 minus 2, and the result is like this one. But I think if in your company you use the class B for the IP address, it's too wasted. Okay, so all the IP address in the same network segment, and after the subnet is divided. For example, we can divide this IP address to become 2 to the power of 8. That means we have 256 class C addresses. And the number of available IP address for each subclass address is 2 to the power of 254 because we have to minus 2. So this is a result. And the decimal of this segment is 172.60.0.0, and the red part is the network part, right? And the blue part is the subnet part. And this blue part length we borrow from the host part. And the last 8 bits is the host bit. So if you make the subnet network to become longer, the host part will be shorter. Pay attention about this part. Your host part will decide finally within the segment how many IP addresses you can use. The network, subnet, and host. And about the binary address is this result. And this is a decimal value. So the subnet mask, if we don't use the classification, we still use the /16 is 111.111.0.0.0.0. So this is a classification. And finally, if you do the subnet successfully, the blue one, you can directly to use different segments. The first part is 000, and the second part is 0001 and 1011. Totally 256 segments you can use. So this is the subnetting. But after you do the subnetting, your mask will become /24. Okay. And the next example for class C, the segment is 192.168.10.213, and the mask is /26. And the mate is, now this is a class C address. The default mask is /24. And the number of subnets is 2. Pay attention, because of the example, we use a mask. We use a mask is 26. And now with the default mask is 24. That means we already use 2 bits as a subnet subnet ID, right? So the number of subnets is 2 to the power 4. If we use the /26, 4 segments we can use. And pay attention, at the last, the customer wants to know which 4 IP address and what's the range. You cannot directly tell that you can use 4 segments, but we have to let the customer know what's the detail of each segment. And the number of valid hosts per network is 2 to the power 32 minus 26. This is 6. Because the mask is 26, the host is 32 long and minus the subnet mask. So the number of valid hosts is 2 to the power of 6 minus 2. That means one segment you can use the maximum number is 62. Okay. And the IP address and the subnet mask, we have to calculate the detail, right? What's the IP address you can make to become the binary system? And the submask is this one. We can calculate and divide the left and the right part. And finally, what's the 4 subnet we can use? We can use this 4. The first one is 10.0 to 10.63. The second is 64 to 127. The third one is this. The last one is this. That means we mix the last 2 bits. We also have 4 combinations, 0, 0, 0, 1, 1, 0, something like this. So this is a result and also is a range. So for example, the first one segment, you can divide for the IT department. The second one, maybe you can divide for finance department. And the third one for the other department, something like this. Pay attention, each segment, the 10.0 and 10.63 cannot be used for customer, because this one is network address and another one is broadcast address. So this is an example. And another one for CIDR, this one also is very, very important. If you deploy dynamic routing protocol in your network, maybe you already use a function of CIDR, classless interdomain routing. And about this technology is used to combine multiple class 4 subnets into one, and then you can reduce the routing entries in the routing table. And this technology, let's see an example. For example, there are 4 segments, right? 0, 0, 1, 0, 2, 0, and 3, 0. When we talk about the VLSN or subnets, we want to make the mask to become shorter, to become longer. But about the CIDR, well, we will make the longer mask to become shorter. Okay. And this is the format of the binary. And we can find what's the difference of this segment. The left one is same, the right one is different. So we can make the difference to become 0. The result is a CIDR. It's 192.168.0.0/22. And you can use this segment to indicate 4 segments. The example is, for example, in this topology, we have 2 routers. Of course, in your scenario, maybe you have the layer 3 switch or maybe the other devices. And we can use the route aggregation to aggregate multiple routes into one. And about the route A, there are 4 segments. The special for route 2 is, if route 2 want to wait 0, 1, the next hop is route 1. But if route 2 want to wait 2.0, the next hop also is route 1. So about route 1, if we have the technology to tell me, I can wait 4 destinations, but the same segment. In my routing table, I only have 1 entry. Okay, because about the entry number, this is a parameter of the devices. You can shorten the entries and the devices check the message and then to follow the traffic will be faster. So this also is an advantage for the devices. So about the route 1, we can do the route aggregation and to only send 1 segment to route 2. And finally on route 2, only receive 1 routing information. But on route 1, we have the detail 4 segments. So about route 2 also can wait this 4 segment destination. Now pay attention about the root aggregation. We have to make sure the 4 segments all exist on row 1. If about row 1, this is if the 1.0 is not on the row 1. If in the row 3, if here we have row 3. But about the row 3, we have the 1.0 segment. Okay. If in row 3 we have this segment, we cannot use root aggregation on the row 1 again. That's because maybe about row 2, row 2 to be the destination of 1.0, I will directly match the routing of this one and then send the message to row 1. Maybe there is a loop. Also, we have another solution to solve this problem. Now, pay attention when you do the root aggregation. All the segments must exist and also is continuous on the devices. This is a key point we have to know on the root aggregation. And also pay attention, you can use the 22 to indicate 4 segments, right? If you use the mask 21, you also can contain these 4 segments, but the range is bigger. This also is not good because maybe route 2, if you use the subnet for 21, route 2 want to visit the destination is 192.168.40 segment. I also will send a message to route 1, but this segment is not exist on our network. So pay attention about this one. This is a CIDR. And how to do the calculation of root aggregation? The first one, we have to convert the address to binary format and align them. Pay attention, if you are familiar of the calculation, maybe you can directly to skip the binary. I think you will be very fast to calculate. And find the last digit that is same in all address. For example, here we can find about this. This is the last bit. The left are same, right? If you find the line is here, these 2 IP addresses is different. So you have to find the last bit in the same in all addresses. And the third one, the number of digits to the left of the virtual line is the subnet mask. But the right one to make all the bits to become 0. And finally, you can get the summary network address. So here is an example. 4 segments, right? 1 for 12, 13, 14, and 15. And the first 60 bits are same. We can directly use the same. But the different one for the third part, right? 0, 0, 0, 1, 1, 0, and 1, 1. Then you will find the left are same. The right one from this part will be different. And then the result means your mask is 22 because 22 bits are same. And the root aggregation is 172.16.00011 and make the rest to become all 0. So the result, you can get the aggregate information. 172.16.12.0 and /22. So this is a root aggregation. So this is a part of the first one, IP address and the subnetting. It's very useful. Of course, when you do the project, if you someone already do the planning for you, it's more easy for you. You only need to get the IP address and then according to the mask, directly to use the command or maybe GUI page, you can directly to give the IP address for customer. For devices, it's more easy. But if you do the planning, you have to know what's the principle. Why we have to use this mask, or maybe the mask is longer better or shorter better. So this is the first part. And here I will have some practice for you. The first one, if we have natural classification network address corresponding to the IP address 112.101, and what's the broadcast address? Pay attention. About this part, what's the correct answer? This is a natural classification. Can you show me some answer? Yes. Anyone can give me the answer? What's the network address? What's the broadcast address?
Broadcast is one to many.
One to many?
So if you have a 255.255.255.255 is the broadcast.
Yes. Okay.
And
Someone told me the broadcast address, right?
and the network address is the beginning of the IP range. So for instance, if it is class A network and slash 24 10.1.1.0/24, so on the network address will be 10.1.1.0 is the network address.
Okay. Thank you for your answer. And also, I see some answer on the chat window. Okay, why I show you these questions for you? Because when you do the planning, you maybe now it's very easy. I provide you the classification address in your real network. When you do the other planning, you also have to skip the network address and the broadcast address because these two addresses cannot be used for devices, right? So how to get the network address? Okay, I see so many correct answers. About the network address and the broadcast address, you have to know the first step is which part belongs to network and which part belongs to the host. And then you know the definition of network and broadcast address is okay. Make all the host part to become 0. This is a network address. And all the host part to become 1. This is broadcast address, right? And then let's come back about these questions. I see this is a natural classification. So we have to know this IP address belongs to A, B, or C. This belongs to class A. Because class A, the IP range is from 1.0.0 to 126.255.255, right? And then make if you know the classification A, the first 8 bits, this is a network. And the last 3 parts will be the host. And then make them to become all 0. So this is a network address, become 192.0.0. And broadcast means make the last 3 bits to become all 1. The broadcast address is this one. 112.255.255.255. So this is a correct answer. It's easy for you, right? Yeah, first host address. That means your 112.0.1 can be used for devices. Now 0.0 cannot be used. This is a network address. The available IP address we also call is the host address. Okay, so this is the first one. The second one, the number of available host address contained in the natural classification network segment corresponding to the IP address 172.15.101 is how many available host addresses in this IP segment. Can you give me some answer? Two to the power of 15 minus 1. Why you need only -1? I think it should be -2, right? Okay. I already see some correct answer. Yes. So subnet. Yeah, this belongs to this subnet. It's correct. So also say this is the calculation process is very similar like the first one. This question is used for you when you do the planning. For example, the customer told you, my department, I have 15 IP addresses in the future. Or maybe I have 150, or maybe 1050, 500, something like this. So how to get the available host address? Also, you have to know who will decide the available host address. Your host base will decide the available address. Your available address. So you have to know which part belongs to the host part, which part belongs to the network part. And the IP address is 172.15.1.1. This is the range of classification B. And then about the classification B, the first 16 bits is a network. And the last 60 bits is a host. And the number of address is 2 to the power of the host ID, and you have to -2. Pay attention. One is network address cannot be used. Broadcaster address also cannot be used. So the result is 2 to the power of 16 and -2. Okay, so this is a correct answer. I think it's very easy for you. Now pay attention. If I add the question, if I add one question like this, if I directly to you, this is the IP address, and your mask is 27. So how many available host address you can use? Oh, yes. This should be 5. If now I already told you your mask is 27, how many available host address can be used? This one is more easy, right? Your host number is 32 minus your mask length. So your host number is 5. And according to the format is 2 to the power of 5 minus 2. So the answer I already see the chat window is 30. So it's very easy for you to do the calculation, right? And the next one, if the subnet mask is 255, which of the following IP addresses are not in the same network segment? If we use this subnet mask, how to judge this IP address within the same segment or not? What's the answer? D? Any other answer? C? Should be C, right? And why I have to ask this question? That's because maybe in the future when we talk about the routing protocol, when the router forwarding the traffic, the first step I have to check will the source and the destination in the same segment or not. Otherwise, your terminal will ask your gateway to help us or direct for the traffic. So you have to know if we have two IP addresses, they in the same segment or not. And how to do the judgment, we have to according to the subnet mask. The bit 1 means they have to be same. and they will be in the same segment. 255 is the first 16 bits. This part, right? If about the two parts they are same, that means in the same segment. If not, only one bit is not. They are not in the same segment. So for options, the option C is different. So the correct answer is C. This is the first part of the IP address because IP address is very important. In the future, when we talk any technologies, we will see some packets encapsulation. And in the encapsulation, we have to add the source IP, your destination IP. You have to know why the IP address format is like this one, and why we ask the gateway on, why we have to calculate the next hop or something like this. It's very important. Okay, so this is the first part. I also see some questions from the chat. Do you get a training certification? Hello, what means training certification? You mean the ISE enterprise or something else? This only is radio technical training. Okay, and where we learn about IPv6. In this training topic, we not include the IPv6. But if you are interested, maybe you can contact to your region. And in the future, we will have the ISE enterprise certification. And in this certification, we will have one topic of the IPv6. 22 mask to 10 valid card. Okay, about the valid card, later when we talk about the ACL, we also will explain about this part. Okay,